Chapter 3, Chemical Equilibrium, Class Life Sciences, Part 6, Identification whether a system is at equilibrium or not. At the end of this session, students should be able to verify whether the system at instant t has attained the equilibrium state or not. Consider the general equation of a reversible reaction. AA plus BB gives CC plus DD, stoichiometric coefficient ABCD, molar concentrations at instant T, A, concentration B, concentration C, and concentration D. In order to determine whether the system at instant T has attained the equilibrium state or not, we should calculate the following quotient. The expression of Q is the same as the expression of Kc, but the difference between Q and Kc that in case of Kc, the concentrations are at equilibrium, while for Q, the concentrations are before the equilibrium. Then, after calculating the value of Q, we compare this quotient with Kc. Kc should be given. We have two cases. If Q equal to Kc, then the system is at equilibrium at this instant. That means the concentrations at instant t are concentrations at equilibrium. But if Q is different than Kc, then the system is not at equilibrium at this instant. It's not at equilibrium. That means one of the two reactions is faster than the other. The reaction which is faster is the reaction that determines the direction of the reversible reaction. When the forward reaction is faster than the backward reaction, the reversible reaction seems that it occurs in the forward direction. When the backward direction is faster than the forward one, the reversible reaction seems to occur in the backward direction. How can we identify whether the reversible reaction occurs in the forward or in the backward direction to establish the equilibrium? We should compare now Q with Kc, less or more. If Q is less than Kc, the system proceeds in the forward direction to reach the equilibrium. How? This is the reaction, reversible reaction, AA plus BB give CC plus DD. Kc, the expression of Q equal concentration of C power C, D power D, over A power A, and B power B. If Q less than Kc, we should increase Q to become equal to Kc. We should increase this quotient, this fraction. How? We should increase the concentration of numerator and decrease the amount of denominator. That means we should increase the concentration of product and decrease the concentration of reactant. Which direction increases the product and decreases the reactant? It is the forward direction. Then the reaction occurs in the or proceed in the forward direction to establish the equilibrium. Then if Q less than Kc, the system proceeds in the forward direction to reach the equilibrium. But if Q is bigger than Kc, then the system proceeds in the backward direction to reach the equilibrium. The same, if Q bigger than Kc, if Q bigger than Kc, then we should decrease Q to become equal to Kc. How? By decreasing the concentration of product and increasing the concentration of reactant. Which direction decreases the concentration of reactant and increases concentration of product? Is the backward or the reverse direction. Therefore, the reaction proceeds in the backward direction to establish the equilibrium. Application. Consider the esterification reaction. CH3COH, carboxylic acid plus alcohol give ester plus water. At an instant T, the composition of the mixture is NCH3COOH equal 1 mole, NC2H5OH equal 3 mole, N ester equal 0.5 mole, and N water equal 0.67 mole. Show that the system is not at equilibrium at the instant T, knowing that Kc for this reaction is equal to 4. To specify in which direction will the system proceed to reach the equilibrium. 1, 3, 0.5, 0.67. Okay, solution. The equation is acid plus alcohol give ester plus water. At instant T, the number of mole of acid 1 mole, of the alcohol 3 mole, of ester 0.5 mole, and water 0.67 mole. To identify whether the system is at equilibrium or not, we should calculate Q. Q, the same as expression of Kc, concentration of ester times concentration of water over concentration of acid times concentration of alcohol. Concentration is number of mole over V for each component. Then we simplify by V, same volume, equal N ester times N water over N acid times N alcohol equal 0.5 times 0.67 over 1 times 3 equal 0.11. We found that Q different than Kc, then the system is not at equilibrium at instant T. In which direction the reaction will proceed to reach the equilibrium? Now we compare Q to Kc less or more. Kc equal 4, Q equal 0.11, then Q less than Kc, then the system will proceed in the forward direction to establish the equilibrium. This is the end of part 6.